Look at part A on your worksheet. We're simplifying square roots. What is the square root of 36? 6. That one was easy. But 24 comes out to be a decimal for 4.9 or so, 4.8. And we don't want the decimal here. We want the what's called the exact answer, which is a simplification. Does anybody remember how to simplify a square root? Chad? No. We're going to factor it. 6 and 4, 2 and 3, 2 and 2. So we have 2 times 2 times 2 times 3. So in order to simplify a square root, we're looking for pairs. Do we have any pairs? We have a pair of 2's. So we circle those 2's, and for every pair, we bring 1 outside of the square root. So 2 square root, what's left? The leftovers are a 2 and a 3. Do we add them or multiply them? Multiply them to get a 6. 2 square root 6. Why do we care? Why bother? Doesn't that look more complicated than the original? Well, we care for the same reason that we care about 4/8 and 6/12 and 3/6 and 10/20. If I gave a problem and everybody had one of those answers, who is correct? They're all correct, but we prefer none of these answers. Which answer do we prefer? 1/2. Well, the same thing can happen with radicals. Often there are many ways to write a radical. And just to make sure that everybody writes it in the same way, we do this simplification. That's one reason. Another reason is, suppose we had the square root of 12 plus the square root of 27. Can I add those together? Not in their current state, but if I alter them a little bit, I can. So 12 is made up of 4 times 3, 2 times 2. Can I bring anything out? A pair of 2's. So I would be left with 2 square root. So I bring these out. What's left over? The 3. What about the 4? What do I need to do with that 4? Well, if it factors, ignore it. So the 12 factored, so we can scribble it out. The 3 was the end of the line, so we kept that. And we went down to a 4, and the 4 became 2 times 2, so we can scribble out the 4. So I'm left with 2 root 3. Now if I factor the 27, 9 and 3, 3 and 3, so I can cross out the 9 and the 27. Do I have any pairs? I have a pair of 3's, so plus 3 root 3. Well, if I have 2 of something and I add 3 of the same something, I now have 5 of them. If I have 2 apples plus 3 apples, I will have 5 apples. And before, if you look up here, I had one pear, one watermelon plus 1 cantaloupe. And you can't add 2 different things together. And by simplifying them, I turned them into the same type of problem, and that allowed me to add them together. So that's why we study simplifying square roots. Okay. We'll get to E in a second. So part C, 216. How do you know if a number is divisible by 2? If it's even. So 2 goes into this. How do you know if a number is divisible by 3? Well, we can't look at what it ends in because 3 goes into 21, that's a 1. 3 goes into 12, that's a 2. 3 goes into 3, so we've got 1, 2, and 3. Multiples of 3 could end in any number, 0 through 9. So that doesn't work. But we do have this little trick. We take 2 plus 1 plus 6. Add up all the digits. And I get 9. If the sum of those digits is a multiple of 3, then 3 goes into the original number. And I don't have any idea why that works. I saw it once. It was really complicated, and I forgot it. So if we look down here at 12, 15, 1 plus 2 is 3, plus 1 is 4, plus 5 is 9. So 3 goes into that number. Okay? How do I know if 4 goes into a number? Well, it's got to be even, but 14 is even, and 4 doesn't go into 14. Well, 4 goes into 100, and 200, and 300. So as long as the number ends in 0, 0, it like 165,200, 4 goes into that. Well, what if I change these last two digits to a 32? Does 4 go into 32? Yes. Therefore, it goes into everything else. So for the number 4, all you have to check are the last two numbers. Does 4 go into 16? Yes. So 4 goes into the whole thing. So down here, does 4 go into 32? Yes. So 4 goes into the whole number. On part G, does 4 go into 15? No. So 4 does not go into 12, 15. 5 does. How do we tell if 5 goes into a number? If it ends in a 0 or a 5, then it's divisible by 5. What about 6? Well, 6 is made up of 2 times 3. So if 2 works and 3 works, then 6 would work. So if it's an even number and you can add up the digits and it's divisible by 3, then it would be divisible by 6. So this is divisible by 3 and by 2, so 6 must go into it. And then, of course, you have 10. How do you know if a number is divisible by 10? Ends in a 0. So if you look at page 6 in your textbook, so there's the rule for 2. The rule for 2 is the last digit is even. The rule for 3 is the sum of the digits is divisible by 3. So if you add up all the digits and it's divisible by 3, then the original is divisible by 3. And then 5 ends in a 0 or 5. But we said that a 6 is a 2 and a 3. So you'll need to remember that. 6 is a 2 and a 3. And there's this funny rule with a 7. If you double the last digit and subtract it from the rest of the number, and the answer is either 0 or divisible by 7, then the whole number is divisible by 7. My recommendation is, if you think it's a 7, try a 7, which is a lot faster than doing this. So there is a funny rule for a 7, but it's kind of hard to do, so don't worry about it. So let's finish part C. Part C says 216. I know 6 goes into it because 2 and 3 worked. So 6 and 36. 3 and 2. 6 and 6. 2 and 3. 2 and 3. Does everybody understand how to run those factor trees? Some people prefer a different method, like the cake method. I can't remember what it's called. Yeah, if you want to do it that way, that's fine. They both work. What am I looking for here? I'm looking for pairs. So I see a pair of 2s. I see a pair of 3s. And I have a 2 left over and a 6 left over. And remember, anything that factors needs to be crossed off. What am I going to bring to the outside? I'm going to bring out one of those 2s and one of those 3s. I have a pair of 2s, so I'll bring those out. I have a pair of 3s, I'll bring that out, and I get 6. Yes, everything that comes out gets multiplied together, and everything that stays in gets multiplied together. Now let's look at the variables. Do I have a pair of x's? How many x's do I have? Just x to the first, which is 1. So the x stays put. Do I have any pairs of y's? How many pairs? I have 4 y's, which makes 2 pairs. So I bring out 1 y for each pair, and I get y squared. Anybody not understand why that's the case? For every 2, I bring out 1. How many y's did I have left over? I had 2 pairs and none left over. So for every pair, you bring out 1, and there were no y's that did not belong to a group. How about z's? I have 7 z's. So I have 3 pairs with 1 left over. So 3 of them come to the front, and then 1 will be left over on the inside. Did any x's remain on the inside? Were there any x's that didn't come out? 1. Oh, well, first let's do, I had a 3 left over and I had a 2 left over. So I have 6. And I had 1 x that stayed behind. How many y's stayed behind? None. So no y's. How many z's stayed behind? Just 1. So 6xz. And that's your answer. Now, what if my original problem would have had a negative in it, a negative 216? What happens when you square root a negative? Not irrational, imaginary. So when you square root a negative, you get an imaginary number that has an I in it. The question is, where do you put the I? Taylor? In front of the square root. So if there's an I, it goes right here. In the homework set, there will be several that need I's. And if there's a negative under a square root, the I goes right in front of the square root. Really, the rule is the I comes last, unless there's a square root. So I's go behind everything, except they go in front of square roots. Let's look at part D. What do I know goes into 6125? 5 does. And if it ends in a 25, I know something else goes into it. 25 goes into it, so let's use the 25. So 25, somebody with a calculator, tell me what that number is. 245, is that right? You're not even impressed I did that in my head. That's what it is. I divided them. 5 and 5. 5 and 250 would be 50, so 49. And then 7 and 7. What pairs should I circle? I have a pair of 5s and a pair of 7s. So I'm going to bring out 5 times 7. On the outside, I get 35. How many pairs of A's do I have? One with 1 left over. So I have 3 A's. Well, are you asking about the 35 or the A's? So I have A times A times A. So I can only circle groups of 2. So I circle one group of 2. For every group, I write 1 on the outside. And then anything that gets left over stays inside. Good question. So I have A on the outside. And if I write my B's out, how many pairs do I have? 2 pairs with 1 left over. So on the outside, I write B to the second because there are 2 groups. For every group, you bring 1 out. So 2 groups, you bring 2 out. And if I write out all my C's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I start circling groups, I end up with 5 groups with none left over. They all come out. C to the 5th. If this were a negative, if it were negative 6125, I would write an I. But it's not negative, so I don't need an I. Square root. What numbers did I leave behind? So if I look at my factor tree, I can cross those numbers off. The only leftover number is a 5. And then I look at the leftover variables. Did I leave any A's behind? 1. So this is A. Did I leave any B's behind? 1B. Did I leave any C's behind? No. So that is my answer. And I know it looks more complicated than the original, but as we go on, you'll need to be able to simplify these in order to make the problems easier and to find a more usable number. Things change a little bit when we get to part E. What's different about that radical? It's a third root. How does that change the problem? It's a 3 instead of a 2. So instead of looking for groups of 2, we're looking for groups of 3. For every 3, we bring 1 out, right? So if we had 2 times 2, that's not enough for a group. You would have to have 2 times 2 times 2 for a group. Yes. So 3 and 9, 3 and 3. Do I have a triple? I have a triple set of 3s. So I bring out a 3. If you bring everything out, what stays on the inside? Nothing, and nothing as a number is, not in this case, a 1. Wait, I thought nothing was 0. Well, there is more than one nothing. What is nothing in addition? What can you add and do nothing? 0. What's nothing in multiplication? A 1. Because 1 times anything is itself. So as far as multiplication is concerned, 1 is nothing. So if we have nothing left over, and we're doing multiplication, we actually have a 1 left over. But the third root of 1 is just 1, so the root disappears, and that's your answer. Just 3. In part F, we have a negative. Is that going to create an I? Not in this case. Why does this not create an I? It's a third root. What is negative 2 times negative 2 times negative 2? Negative 8. If you have 3 negatives, that's the same as 1 negative. If you have 2 negatives, that's the same as a positive. So if the root is odd, If you have an odd root, you have no i's. But if you have an even root, you have i's. So if it's a fourth power, you need an I. If it's a fifth power and it's negative, you just bring the negative outside. Looking at part F, what do we know goes into 432? 2 does. Does 3? 4 plus 3 is 7, plus 2 is 9. 3 works. Does 4 work? Yes, because 4 goes into the last 2 digits. So if 4 and 3 works, 12 must work. 4 times 3 must work. So let's divide it by 12. 12 and I don't know what the answer to this one is. The higher it is, the shorter the problem's going to be. But if you wanted to start with 2, it would just be a really long factor tree. You'd still get all the right answers, though. 12 and what? 36? 12 times 36. So 4 and 3, 6 and 6, 2 and 2, 2 and 3, 2 and 3. So there's a lot here. I'm going to cross off the ones I don't want. What am I looking for? I'm looking for triples. What triples do you see? I see triple threes. Looks like a llama. So my outside number is going to be close. -6. I'm going to pull that negative out front. So -6. Now I look at the variables and I'm looking for triples. How many triples of A are there? 1 triple. So I can write 1 on the outside. How many triples of B are there? 1 with 2 left over. So I can pull out a B, but there will be a B squared on the inside. How many triples of C are there? 3 triples with 1 left over. On the inside, the only number I left behind was a 2. Do I need a negative on the inside? No, I pulled the negative out. So 2, how many A's? None. How many B's? So B squared. How many C's? C to the first. You guys kind of getting the hang of this? It's not too bad. Oh, you don't have to cross them off. So this crossing the numbers off, that's just to remind me that they're not part of the answer. If it factored, we just ignore it. The 2 is the end of the line. If a number branches, we scribble it out. But if a number doesn't branch, then we use it. That's a good question. Letter G. Does 2 go into that, what is it, 1215? 2 doesn't work. Does 3 work? 1 plus 2 is 3, plus 1 is 4, plus 5 is 9. 3 goes into 9, so that works. So 3 works. Does 4 work? No. Does 5 work? Yes. So if 3 and 5 work, then 15 must work. So 15, somebody multiply that out for me. 81. 5 and 3, 9 and 9, 3, 3, 3, 3. Oh, sorry. That should be 3 and 5. What am I looking for? Quads, groups of 4. If there was a negative, would I pull out an I or a negative? How come an I? It's an even root, so negatives would create imaginary numbers. But I don't have a negative, so I don't need to worry about it. There is my quad. So I can pull out a 3. And some people like to do both sides at the same time, so we'll try it. And don't forget to write your little 4 there. I think I forgot that on the last one. You have to make sure you label that root correctly, that radical correctly. Can I pull out any A's? No. So they all stay on the inside. How many numbers stay on the inside? The 5 and the 3, which gives me 15. A to the third. How many quads of B do I have? 2 quads with none left over, so B squared on the outside. How many quads of C do I have? 3. I get rid of 12 of those C's. 3 groups of 4. So C to the third with just a C left over. So if I were to line up all 13 C's and count off groups of 4, I would get 3 full groups with 1 remainder. So the 3 come out and the 1 stays in. All right? Letter H. What do I know goes into that? 10, 20 works 2. 10 and 32. 5 and 2. 8 and 4. 4 and 2. 2, 2, 2, 2. There are a lot of numbers there. So just to make it easier to see, I'm going to scribble out the ones that factored. What am I looking for here? Groups of 5, what would we call that? Quints? I don't know. I might be making up words. Pentas? Yeah, that might be it. If there was a negative, would I pull out a negative or an I? A negative because it's an odd root. So as far as groups of 5 go, I have 2 with a 10 left over. So 5 of those 2's come out, and a 2 and a 5 is a remainder, so it stays inside. How many X's can I pull out? None. I need 5, and I only have 3, so X to the third on the inside. How many Y's can I bring out? 1. How many are left over? None. I brought all 5 out. How many Z's can I bring out? 2 groups of 5. So Z squared. How many left over? Z squared left over. And don't forget your 5th root symbol. All right. Your worksheet is the rest of your assignment. There's a lot of work to do, so don't waste the next 8 minutes.